Chapter 6, Section 4. We're going to learn, and obviously you guys went over and you took pictures of the law of exponents poster up here. You got it, because this is the kind of stuff we're going to learn about today. And what fractions, and what they have is rational exponents here, they say. This is your learning target for today, by the way, rational exponents. Well, don't matter. Rational, well, he might ask you when you go out. When you look at, when I have let's start with this one, the square root of x, or if we think of it as a 2 in there, okay? If we think of it as a 2 in there, that's really writing it as x to the 1/2. We did this already on calculators, remember that? We did this. We were able to take it and figure it out. So a lot of this stuff might be review for you. All right? If I have, let's say, x to the 3rd inside and it's a square root out here, it's like raising this to x to the 3/2. All right? Yes, Lynn? Sure. You can interrupt my recording. All right. So we've learned this stuff already. Here's what else can happen. When you take two exponents, let's say x to the 3rd times x squared. All right? So we've got two exponents. We don't multiply these exponents, we add them. This is like x to the 3 plus 2, or x to the 5th. All right? So if we have something that says x to the 3/2 times x to the 1/2, okay, x to the 3/2 times x to the 1/2, we add those fractions. X to the 3/2 plus 1/2, which would equal x to the 4/2, or x squared. Do you see how we get that? Okay. She does. She's keeping good notes, like you should be keeping good notes. Yeah, that's what scares me. Yeah, but it's rusted shut. All right. So if I had x to the 3rd divided by x squared, everybody should know what this is, right? It's the same thing, though, as saying x to the 3 minus 2. Because we're dividing, we would subtract those exponents. And it would just be x to the 1, or x. All right? So, the first part of what we're doing on this is doing just that. We're multiplying. Now, no, I want you to recognize something too. This, before I go any further. If I had x to the 4th times y to the 3rd, can we combine those? No. Why? Different bases, right? It's like having 5 squared times 2 to the 4th. As they stand, we can't combine them. If we actually did 25 and then 16, 25 times 16, we could do it. But we can't combine these two because the bases are different. So when you look at this, you have to first make sure you're doing it with similar bases. So if I give you something like this, x squared y to the 4th times x to the 5th, you can combine the x's but not the y. So this would be x to 2 plus 5 y to the 4th, or x to the 7th y to the 4th. Okay? You can only combine them if they have like bases. So, if I did this, 2x times 5y, let's say xy. If I multiplied those two together, what can I do? 2 times 5 is 10. X times x is x squared, and then y. Okay? Why not? All right? Did everybody see how that works? There's 6 problems there we're going to work on, and you have to work with those. Here's 3 of them. Well, let's take a look at page 2. Mr. Drama. Yeah, it was yeah. All right. So let's take a look at basically the same thing we were doing, right? If I have, but here's what happens. If I have a negative now in there, so if I have x to the negative 1, all right, but what does negative 1 mean? It means 1 over x. If I had x cubed, the negative cubed, it means 1 over x cubed. All right? All the negative does is it puts it in the bottom. Remember I did this, x cubed over x squared, x the third minus 2 when I brought it up. It's the same thing as what I showed you before, except now we're just looking at it as a negative number. Negative number puts it down into the denominator, or reverses. If I had 1 over x to the negative squared, I just bring it up and make it x squared, right? It reciprocals it. Okay? Understandable? Schmods. Let's take a look at what we got here. Oh, we got to raise these to the power. Oh, we got to do those too. Hold on. No. X squared to the third. Okay, so I'm raising it to another power. I'm taking x to a power and raising it to a power. Think of it this way. This is like saying x squared times x squared times x squared, right? Which would be 2 plus 2 plus 2 is 6, right? X to the 6. So what are we really doing here? We're multiplying. When you raise it to another power, when you raise it to another power, you multiply. Okay? Now what happens if there's fractions in there? You guys like fractions. X to the 1/3 raised to the 6th power. X to the 1/3 raised to the 6th power. Yeah. X is 6 over 3, or x squared. X to the 18th. Where do you get 18th? Goofus. All right. All right. X to the 1/3 times raised to the 1/4 power. X to the 1/12 power, right? Multiply. Numerator times numerator, denominator times denominator when you multiply. You guys can do that? You'll crank out 18 of them, no problem at all. Okay, I won't be like that. This is what you got to do. On this page here, do 7 through 18. And on the other page, good idea. Thanks for saying that. I don't have to go to the other page now. 1 through 6 on the other page. Okay, do the evens. And then after that, do the odds. Do the odds. Just do the odds.